Hey everybody, welcome back. In this chemistry lesson, we're talking about molecules and an introduction to covalent bonds. So, what are molecules? Most atoms in the universe and in our bodies are attached to other atoms with what we call bonds. And the combination of two or more atoms together is called a molecule. Molecules form because most atoms have an incomplete set of electrons in their valence shell. Atoms create bonds with other atoms so that they can both have a full valence shell and become stable. Let's look at an example of two different types of atoms that will help us understand why atoms form bonds with other atoms. We'll start with fluorine. Fluorine has atomic number 9, meaning that when it's in its neutral state, it has 9 protons in the nucleus and 9 electrons. So here's what a neutral fluorine atom looks like. We draw the F in the center representing the nucleus. We know that there's 9 protons there. Then we have to draw 9 total electrons outside in the electron cloud. Shell number 1 gets 2 electrons and shell number 2 gets 7 electrons. And now you can see the problem. Fluorine only has 7 electrons in its valence shell. This makes the atom extremely unstable. It really wants to have 8 electrons in that second shell. So a neutral fluorine atom will quickly react with other atoms in its environment to gain an electron, form a molecule, and then become stable. Now let's draw a neon atom. Neon has atomic number 10, so it's very similar to a fluorine atom but different in one very important way. So we'll start by drawing the nucleus and then 10 electrons outside of the nucleus. Once again, you notice that electron shell number 1 has 2 electrons and shell number 2 has exactly 8 electrons, and that's the valence shell. This is very important to notice that neon has 8 electrons in its valence shell. So it's very happy, very stable, and very unlikely to bond with other atoms. A neon atom is perfectly happy by itself. So we call an atom by itself monoatomic. Next, let's talk about covalent bonding. Covalent bonding is one of the most common types of bonds that create molecules in our body, throughout the world, and in the entire universe. A covalent bond is formed when atoms share electrons from their valence shell. That's why it's called covalent bonding. The prefix co means together, and valent refers to the valence shell. In covalent bonding, the valence shells have come together. They're overlapping. That's one way of looking at it. If the valence shell is shell number 1, the atom is most stable when there are 2 electrons. If the valence shell is any other shell, always remember that the atom is most stable when there are 8 electrons. Bonding between atoms only involves the outer or valence electrons, not the other electron shells. Here we have an example of hydrogen gas, which is a very simple covalent bond. You can see that each hydrogen atom by itself only has 1 electron in that valence shell. It's very unhappy in that state, unstable, and it desires to join with some other atom so it can have a full valence shell. 2 hydrogen atoms can come together and share their valence electrons so that they both have 2 electrons in their valence shells. This type of molecule is called diatomic because it's made of 2 identical atoms. Take a good look at this picture because now I want you to try to draw a diatomic hydrogen molecule by yourself. This is your opportunity to draw the molecule that we just discussed. Try to draw this on your own and then I'll show you how to do it. So diatomic hydrogen is a gas that we abbreviate as H2. And here's how we can draw it. We'll start by drawing the first hydrogen nucleus with that valence shell. Then we'll draw the other hydrogen nucleus with its valence shell. We know that each hydrogen atom is only bringing 1 electron to this relationship. So we'll draw 1 electron here in the shared valence shell, and then we'll draw another electron here representing the electron deposited from the other atom. So this is a description of what we call a single covalent bond. It's called a single covalent bond because each atom is only contributing one electron, and that makes two total. So you can think of it like this. It's one set or one pair of shared electrons. Here's another example that you can try on your own if you'd like. Draw a diatomic fluorine molecule, which we write as F2. Pause this video and take a second to try to do it on your own. The diatomic fluorine molecule is going to be a little bit different because now we're dealing with shell number 2, which can contain 8 total electrons, and because it's the valence shell, it needs to be organized in a way where it can have 8 total electrons. So we'll start by drawing the first fluorine atom and its valence shell. Notice that we're only drawing the valence shell in these illustrations. We don't need to draw the first shell, we're only drawing the second shell, which is the valence shell. Now we'll draw the other fluorine nucleus with its valence shell, and we have to decide where we're going to put all of these electrons. Fluorine is from group 17, so we know it has 7 valence electrons, and one of those electrons is going to be shared with the other fluorine atom. Now we'll draw the electrons for this other fluorine atom. We'll draw all 7 of them, and one of them is being shared with the other fluorine atom. So when you look at the number of electrons in the valence shells for both atoms, both of them are satisfied now. The fluorine on the left has 7 of its own valence shell electrons plus one more that it's borrowing from the other atom, and then it's the same for the fluorine atom on the right. The fluorine atom on the right has 7 of its own valence shell electrons, plus it's getting one more from the fluorine atom on the left. And so once again, when we're sharing one set of electrons or one pair of electrons, we call that a single bond. Here's another example of a group 17 atom that's going to look very similar. We're going to draw a diatomic chlorine molecule. So 2 chlorine molecules together that have formed a single covalent bond. And it's really going to look almost exactly the same, except for the nucleus, it's going to be chlorine instead of fluorine. So on the left, we'll draw the chlorine nucleus represented by the red circle with just the valence shell on the outside. Then we'll draw the other chlorine nucleus with just the valence shell. We don't need to draw the inner shell. Now we need to draw in where all of those electrons are going to go. Remember, chlorine is a group 17 element, so it has 7 valence shell electrons. Then we'll draw the same valence shell electrons for the other chlorine atom, and now both atoms are perfectly satisfied. The atom on the left has its 7 valence shell electrons plus one more that it's sharing from the other atom, which gives it 8 total, and then the atom on the right is doing the same thing. It has 7 valence shell electrons of its own plus one more to make 8 that it's sharing from the other atom. And once again, this is called a single bond because these atoms are together sharing just one set or one pair of valence shell electrons. There's other ways that atoms can form covalent bonds. The sharing of 2 sets of electrons, that would be 4 total electrons, is called a double bond. Oxygen gas is a common diatomic element that forms a double bond. A double bond is necessary because the valence shell of oxygen is 2 electrons short of 8. So let's take a minute and draw what that looks like so we understand the relationships. Once again, we'll begin by drawing the nucleus of an oxygen atom, which is represented by the red sphere with an O in the middle. Then we'll draw the valence shell. We'll do the same thing for the other oxygen atom. Now we need to place these valence shell electrons. Oxygen is a group 16 element, which means it has 6 valence shell electrons. So we've drawn 6 valence shell electrons, 2 of which are going to be shared with the other oxygen atom. Now we're going to draw the 6 valence shell electrons for the other oxygen atom and count carefully to see how both atoms are now perfectly satisfied. The oxygen atom on the left has 6 total valence shell electrons plus 2 more that it's sharing from the other atom to bring it to 8 total. And the oxygen atom on the right is doing the same thing. It has 6 valence shell electrons of its own, plus it's borrowing 2 more from the other atom to make it 8 total in its valence shell. And this is what we call a double covalent bond. It's called a double covalent bond because each atom is sharing 2 of its own electrons. In other words, you can think of it as being 2 shared pairs of electrons. So that's a double bond, but covalent bonding can also be a triple bond. The sharing of 3 sets of electrons, that would be 6 total electrons, is called a triple bond. Nitrogen gas is a common diatomic element that forms a triple bond. A triple bond is necessary because the valence shell of nitrogen is 3 electrons short of 8. So let's draw a picture of what that molecule would look like. We're going to draw diatomic nitrogen, or N2. As before, we'll begin by drawing both of the atoms with their valence shell. We don't care about drawing the inner shell at this point. Nitrogen is in group number 15, which means it only has 5 valence shell electrons. So we'll draw all 5 of those and notice that 3 of them are going to be shared with the other atom. Then for the atom on the right, we're going to draw the same thing. All 5 valence shell electrons for nitrogen, and 3 of them we're drawing in the center over that shared area to indicate that this is a triple bond. A triple bond means that each atom is sharing 3 of its own electrons, which we can also describe as sharing 3 total pairs of electrons. So far, I've only showed you diatomic molecules, that is, molecules that are formed by the sharing of electrons between 2 identical elements. But there's lots and lots of covalent bonds that do not involve identical elements. In fact, water is an example of this. Water is formed by the covalent bonding of 2 hydrogen atoms with an oxygen atom, and we write that as H2O. So right now, let's practice drawing what a water molecule looks like. We know that there's 2 hydrogen atoms and 1 oxygen atom, but let me show you how those are going to be arranged together in a molecule. We'll start by drawing the oxygen nucleus with its valence shell in the center of the screen. Then we need to draw both hydrogen atoms on either side of the oxygen atom. Notice that they're not perfectly in line. There's actually an angle here. The reason that there's an angle and not a perfectly linear molecule is outside the scope of this lesson. So we know the hydrogen atom only has 1 electron to share. So we'll draw 1 electron there, and in order for that hydrogen valence shell to be satisfied, we already know it's going to have to borrow an electron from the oxygen atom. We'll draw the same thing on the other side. The other hydrogen atom also only has 1 electron to share, which means it needs to borrow 1 more from the oxygen atom in order to be satisfied. And we know that the valence shell of an oxygen atom has 6 total electrons by itself, so we can draw in 4 more electrons. And notice all atoms are now satisfied. Both hydrogen atoms have exactly 2 electrons in their valence shell, and because of the single covalent bonds that it forms with the hydrogen atoms, the oxygen atom is also now satisfied. It has 6 of its own valence shell electrons plus 2 more that it's borrowing from the hydrogen atoms. Let's look at another kind of molecule that's similar but different in some important ways. Now we're going to draw a carbon dioxide molecule. So we'll begin, as we've done before, by drawing the atoms that are involved. We have a carbon atom in the middle with an oxygen atom on either side. So let's draw in all of the electrons for all of the relationships, and I'll explain where they came from. Remember, oxygen is a group 16 element, so it only has 6 valence shell electrons on its own. So it has to borrow 2 more from the carbon atom. The other oxygen atom is going to do the same thing. It only has 6 valence shell electrons on its own, so it's borrowing a pair again from the carbon atom in the middle. The carbon atom by itself only has 4 valence shell electrons, so it has to borrow a pair from 1 oxygen atom and then another pair from the other oxygen atom. And now, if you count all of the valence shell electrons, including those that that each atom is sharing from another atom, each atom is now satisfied. Each atom now has 8 total valence shell electrons. And notice that these are double bonds because each atom is contributing 2. So there's 2 pairs apiece contributing to these double bonds. So that was an introduction to molecules and covalent bonding. If you have any questions or comments, please leave those in the comment section below. Thanks for watching.